Math 7 Faithful. Welcome back to Lesson 4. This is our final lesson before the quiz. And today we're talking about proportional versus non-proportional relationships. As you know, it's related to rates and unit rates and all things to do with ratios and all that good stuff. So let's find out, what does it mean if something's proportional or not non-proportional? All right, here we go. So first way to check if something is proportional is if it has a constant ratio or a unit rate, okay? So if something's proportional, it has a unit rate. Every $2 you make, you get 1 gallon of gas, all right? So $4, you get 2 gallons. $6, you get 3 gallons. That is a proportional relationship. For instance here, right, the number of pizzas you order, you get $8 for 1 pizza, $16 for 2 pizzas, $24 for 3 pizzas. This is proportional. It continues at the same rate. Okay? There's nothing that changes that. It's a constant rate. Nothing's changing that. It's called equivalent ratios. When you have ratios that are equal, they reduce to one another. Okay, they slide down. As you reduce them, they equal the same rate. And the unit rate is the most reduced version, and all these other ones are just the equivalent ratios of the same thing. Okay, and here's your unit rate over here, $8 per pizza. So Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the amount of money he earns per mowing? So let's check it in a table. $18 for 1, $36 for 2, $54 for 3, $70 for 4. Are these all the same rate? Are they all the same ratio? If you reduce them all, 18, 18, 18, 18. So yes, this is proportional. Boom. All right, at Lakeview Middle School, there are 2 homeroom teachers for 48 students. I always put the bigger number on top, just makes it a little easier. You don't have to, you can do it the other way too. Is the number of students at this school proportional number of teachers? So let's say the next ratio would be 4 for 96. Does this reduce to the same rate? Or you could reduce this. Are these equal, right? Divide by 2, divide by 2. Yes, they are equal. If I reduce it even further, you get 24 students per 1 teacher. Okay? What we know is that the rate of students per teacher is 24 for every 1. This is proportional. All right, now let's look at this table here. $10 for 1, $17 for 2, $24 for 3, $31 for 4. So 10 divided by 1 is 10. 17 divided by 2 is 8.5, and we can stop here. This is new. This is not proportional because they're not the same unit rates. The unit rate has changed. As you order more tickets, you get a discount. Now the tickets are only $8.5. Over here, they're only $8. And over here, they're $7.75, I want to say. I'm not 100% sure about that. I'm just guessing. Oh, there it is. Okay. Same thing, whether you have fractions in there or not, you can still do the division. 1/2 divided by 1 is 1/2. 1 divided by 2 is 1/2. 1 and 1/2 divided by 3 is 1/2. 2 divided by 4 is 1/2. So it doesn't matter if the bigger number's on top or the smaller number's on top. You can go the other way. You can divide up if you want. You can divide down if you want. It's if the numbers come out the same, that's the key. All right. At the beginning of the year, Isabel had $120 in the bank. Each week she deposits another $20. Okay, so after week 1, it was $140. Week 2, it was $160. Week 3, it was $180, right? So every week we add $20. She started with $120. Is this proportional? 140 divided by 1 is 140. 160 divided by 2 is 80. This is not proportional because they don't have the same rate. So the key to proportionality is, do they have a unit rate? Are the rates the same every time? Okay. Usually you can tell within the first 1 or 2. Let's do one more. We're on page 36 now. Okay, let's go down here. Which situation represents a proportional relationship between the hours worked and Matt and Jane? Okay, so let's check. 12 divided by 1 is 12. 20 divided by 2 is 10. So right here, no, not Matt. Let's check Jane. 12 by 1 is 12. 24 divided by 2 is 12. 36 divided by 3 is 12. So Jane is proportional. Matt is not. Explain. I just